Greetings, welcome to the final video of the 2019-2020 Distance Learning Series. Today we're going to talk about the area formula for a bunch of different shapes. Now, I know most of you are like, why do I need to memorize area formulas for different shapes? In truth, you could look up all of them. But there is something to be said for knowing a few. Okay, it's not just like you should know your times tables, you could work it out by repeated addition, but you should just know a few. Okay, and I'm going to go into not only the few that I think you should know, but I'm going to talk about where those formulas came from, why it is the way it is. Okay, really only going to look at about 4 or 5. I think 4 would have been 5 if we had needed to include circles, but we did circles last week. So let's take a look. I'm going to start with the one that everybody here knows, and that is poorly drawn, but a rectangle. So we include our little boxes to tell us that these are right angles. Okay, and squares are a form of rectangle, so we're not going to differentiate them. I know some places do that. We're just not going to. Okay, so we talk about the area of a rectangle, and I hope that all of you know this one as length times width. Okay. Now, the nice thing here is because you're going to multiply them together, which one you actually call the length and which one you call the width really doesn't make any difference, but we're going to be traditional here. We're going to call that the length and that the width. Now, again, why? You all know that formula. You've all said, hey, I got that formula. But let's talk about why that formula is what it is. Okay? Think of it like a farm. Okay? And each one of these lengths would be like a row of grain, for example, maybe a row of corn. And you want to know, well, how much do I have? How many rows of corn do I have? Well, you take that rows of corn, each one of these lengths would be a row of corn, and you'd multiply it by, well, how many of these rows do I have, which would be your width. That's where this comes from, okay? That's why this is such a great formula, okay? And it's also, this is stuff that kicks in when you start to look at, building anything, okay? A fence, house, a barn, a whatever. Because one of the big issues that comes with building is cost of materials, right? If you can get the same amount of square footage by building something that's 400 feet long and 1 foot wide. Not very usable, 1 foot wide, but 400 feet long, that gives you 400 square feet. But if you built something that was 20 feet by 20 feet, so 400 feet times 1 foot would give us our 400. And 20 by 20 would also give us 400. But you'll find there's a lot less building material in that 20 by 20 because of the perimeters. And we'll work on those, we'll talk about those some other time. But if you just are ever wondering, well, why do I care about these things? Well, when you go into building or buying or developing or any of the things construction-wise where you might have some vested interest, maybe it's just buying your own home, okay, you'll find that squares are the most efficient use of space for building materials. And obviously 400 by 1, not so efficient, kind of long, kind of not really usable, but it's the same amount of space. Okay, and obviously that's important to us. So there's our length times width for our rectangle. Now the second most, probably the most important, not even the second most, the most important shape is the triangle. And the formula for the area of a triangle is, again, another one of these ones where not only do I think you should know it, but every math teacher you're ever going to see is going to assume you already know it. Okay, and that formula is base times height divided by 2. And sometimes you'll see it written this way. And again, the B is for base. And I know this seems like a little thing right now, but trust me, use a lowercase b. It actually makes a difference when we get into stuff where you'll start to deal with areas of three-dimensional shapes. You'll be using a capital B. So it'll actually make a difference. And then H is our height. Now, I would hope this formula actually kind of seems pretty clear to us. Why is it base times height divided by 2? Well, if we look back at our rectangle up here, which was our rows of corn, if I just were to draw a diagonal line through the center of it, you can see I've cut it into two triangles, one on the top, one on the bottom, and this is just the bottom triangle. So I've cut it into two identical sized pieces. This is one of those two identical sized pieces. So 1/2 base times height. You could say 1/2 length times width if you want. Now, it becomes a little more concern when you don't have that little right angle developed. What if the shape was that kind of triangle? Well, I don't have, what's my base, what's my height? And you got to be very careful. This is where mistakes happen and students just want to run right out and grab whatever numbers they see. The base and the height. Base and height are always, and there are very few times when you can say always in math. Never and always, just there's almost an exception to almost every rule, are always at a right angle to one another. So if I don't see that little box, then I know I don't have a base and a height. I'm looking for that. So if I want it, oftentimes it'll look like this. They'll have like a dotted line down the middle because it's not one of the three sides of the triangle. And then there's that little box. And all of a sudden, all my information is there. So now this is my base. And this is my height. Okay? No matter how, and that could be outside the shape. It could be part of the shape. Okay? This would be my height. This would be my base. It could be inside this shape, down the center like this one is. It can be all over the place. Okay? Base times height. Okay? In fact, you're going to find you need a right angle pretty much for every single of these area formulas that involve shape. So rectangles, triangles, okay, parallelograms, same situation, okay, same formula, still length times width, just again following this rule that the height and the base have to be at a right angle to each other. So if we have something that looks like this, then we need a right angle off to the side somewhere again so we can have our height and our base. Same formula as a rectangle because it's four sides. Okay. The only other one I want to introduce us to is one more. Okay. So again, a square is just a rectangle. Okay. Parallelogram, very similar. Really, these two are the important ones. There's one more that's a little tricky, and that is something called a trapezoid. Okay. So a trapezoid, what distinguishes a trapezoid is that it has two sides that are parallel. That's about it. So these two sides, so this becomes base number 1, and this becomes base number 2. Okay, and we'll indicate that with a little lowercase. So this will be our b sub 1, this will be our b sub 2. And again, just like in the triangle, just like in the rectangle, I need a right angle. So I'll drop this right angle right there in the middle, and again, that will become my height. And again, you can pause at any time, rewind, rewatch, you know the deal. The height. Now this formula here gets a little tricky. It's a little weird. Okay? What you're doing is you realize you kind of have two rectangles. You have like a small one on the inside and you have like a large one on the outside. So what are we going to do? We're going to find the average of those two rectangles. So we're going to find the average of those two bases. So what we get is we get a B1 plus a B2. All of that is divided by 2. That's the average because there's 2. You add them up and divide by the number of them that there are. So in this case 2 to find the average. So now we have the average of these two bases. We multiply that by the height and we have our area of our little trapezoid. And those are the three formulas you really kind of need. Okay? We need the rectangle, which is also parallelograms and rhombuses and almost anything with four sides where you have some right angles. You need the triangle, which is really the same formula just divided by 2. And then this kind of strange one, okay, trapezoid, because this comes up a little more often than we like it to, and it's a little weird. Now, what's interesting is that this formula would work for the rectangles too. If you really wanted to go that direction, you could use this formula to find the area of the rectangle. It would work. It's just it's extra work because you would be averaging two values that are of exactly the same amount. If these are both, because if this is the length, you'd say length plus length divided by 2 gets you length again. So you could do it that way. But these are the three formulas you need for this week's assignments. Again, this is going to be a short week. Feel free to contact me if you need to. Come to my office hours just to say hi or bye, because this is our last week. All right, it's been fun, and good luck to you next year.